So all of you join this code. 1 minute, let me share it. This is the code. Please, everyone who is here, join this. Just go to the joinpt.com and put this text. The code is TXK. Triple I is there. So all of you try this problem. This is the first problem. The question is, what will be the constraint equation? Constraint equation we want for the case when you have a maximum 3 hours time to solve whole question paper. If it takes 10 minutes to solve a MLF problem, 12 minutes to solve mathematics problem, and 5 minutes to answer English. What is going to be the constraint?
Yeah, see, sir.
Okay.
Sir, C option.
Okay. Okay, so it is easy. 3 hours is maximum, means anyhow if 10 minutes is MLF. Okay, and next problem is there, then it will be 10x, and then 12 minutes is to solve a mathematic problem where you have y problem, so it would be 12y, and similarly 5z, and all are actually in minute, so you have to choose it minute. So all of you have chosen, okay, somebody have chooses option B. Option B is not going to be correct option. The reason is it is this side is in minutes. If you be bound on the unit side, in which unit it is. So this left side is all in minute and the right side is in hour. So we have to change in hour. Then the balance would be in a unit, like a uniform unit would be. Okay, so this is an easy problem. Let's do next problem.
Sir,
Anyone
what
have any
was the
doubt? Yeah.
answer?
So C option is the correct option.
Okay, sir.
Anyone have any doubt on this?
No, sir.
No, sir.
Okay, let's do the next problem. We have this we have some points 0, 0, 0, 2, 2, 2, 2, 6 form of convex hull. Which of the following points are the part of this convex hull? So we have discussed last time a lot on convex hull. So which option going to be the, which point is going to be the part of that convex hull? Okay, option D only. So how are you choosing? Option D is only the part of that convex hull.
So
So, how
essentially,
to solve this?
if we mark all the four coordinates given, sir, 0, 0, 0, 2, 2, 2, 2, 0, we get a kind of square in the first quadrant. And we need to find, we can visually easily figure out which of the following points fall into the first quadrant of that space, which the only one that falls is 1, 1.
One. Yeah. Any different method anyone got? Yeah.
I think we can also try, applying the lambda for x coordinate, which is ranging from 0 to 2, and
Okay.
also for y coordinate, which is also ranging from 0 to 2. And for
Okay.
any lambda, it has to be between 0 and 1 for x and also for y.
Okay. This what you want to say something?
Sir, could you please explain this question?
Yeah, I will explain. Anyone have any different idea? Answered by different idea. So there are two things. By two way we can easily answer is we have one, if you draw the points, the points are 0, 0, 0, 2 and 2, 2 and 2, 0, I think. Yeah. So these are the points we have. Now, if you think what is the convex hull, so Convex hull is nothing but, we have the definition of the convex hull using this point is going to be the set where lambda 1 plus lambda 1 0 2 plus lambda 2 or maybe 0 0 and then 0 2 plus lambda 3 and 0 3 2 2 plus lambda 4 0 sorry 2 0 where the constraints are lambda 1 lambda 2 lambda 3 and lambda 4 going to be 1 and all lambda I should belongs to 0 2. But this is the convex hull definition. Is it correct?
Yes, exactly, sir.
Yes, sir.
So in different idea, it is actually telling you, what is the meaning of that. See, we know the convex. This is a convex set. The convex hull is a convex set. Or in different idea, if we choose, a kind of, so if this set is going to be this portion. This portion. Anyone answer why it is so? Why this is going to be?
Because lambda, any of the lambda I has to be between 0 and 1.
Between 0 and 1.
Any lambda I.
Okay.
So the x coordinate cannot exceed the 2 and y coordinate cannot exceed 2.
Okay.
And likewise, it cannot go be less than 0 as well.
Okay. So the picture, why the picture would not be this one kind of circle?
Because those points, lambda will not support, sir, because lambda has to be positive, any lambda has to be positive, so it doesn't support for it to
So
go.
let's say why this is not okay. So I'm not going to be this side only, this side.
Okay.
Why this is not?
Here it is not possible because lambda cannot go beyond 1. Any lambda.
Okay. Yeah. Okay. So yeah.
These points are convex set, and if we intersect these 2 points, so basically, if we take lambda 0 and 1, then ultimately the value come to be these points only.
Yes. So that is what. Yeah, that is only if we are going to be a combination.
Lambda x1 plus 1 minus lambda x2 for the convex set.
Yes. So simple reason is we know, right? No, convex. We say generally, a set is convex when we are choosing that 2 points, any 2 point, the line segment joining these 2 points should be within that set. So we are making. This is a kind of this one is that we are choosing the lines. If you draw all fill up with lambda is between 0 to 1 only, any real number it is. So if you choose this one only, so if you possibly draw, so these are all going to be within that. So this one is going to be within that. Similarly, this one is going to be within that. And okay. And also see, this is all going to be one this kind of, and also we are choosing all, no, here the lambda i's are going to be anyhow within that. So lambda I is connecting with all this on all. It is not becoming one is 0 and other are non-zero. It is going to be like that. So that's why this a reason is, whatever the reason is becoming here, is going to be this convex hull we are getting, that is a square. And the second reason is simple, is that here if you see, if you want to neglect option, so here the entries are, minus, minus, minus. But we are we see, right, the here the whatever this is always positive, this all lambda is positive because this is between 0 to 1, and here the entries are always positive. So how one point could be negative? Any of the point here, how you will get the negative if you are solving these all? And so when we are doing this numbers, when solving this number, we only get the positive. If you are ending with, we end with the positive numbers. This coordinate is also positive, and this coordinate is also positive. It is nowhere going to be negative. So if you match with that, only the D option is going to match. Yes, Prasad.
Sir, I have a doubt, sir, related to the convex hull and convex set. How they are different? They sound same to me, both same to me. Convex set.
Only one difference is there. Convex hull is you are creating a convex set using some points.
Mhm.
Okay. And convex set is already you have a set, and you are checking that is that set is a convex or not.
Basically, convex hull is the intersection of all those points containing.
In the second, yeah. So best thing is, so convex hull is all possible. What
All
is that?
possible linear combinations of those 4 points, actually.
That is a, in the word of intersection. What is the definition? Uh,
No, all possible linear
San,
combinations of those 4 points, no, sir?
Intersection of
San,
the all convex set, those contains these points.
okay, intersection of all those,
All convex sets which
Mhm.
contains these points.
All convex sets which contain these points. Okay, this is another definition. Yeah, correct.
Yeah, can you help me visualize that, if you don't mind, Sanya Kumar?
For visualizing, mm, this sir has explained, like if you take these, if you take 2 points of this, then it, if you intersect these 2 points, then it makes a convex set, right? Like you can't take a curve for those points, like 2 comma 0 and for 2 2, you can't take curve. If these are two convex sets, then you intersect with this line segment, and this like line segment represents that uh, equation, that is lambda x1 plus 1 minus lambda x2.
So
You
here
said actually,
always, so always see, one thing is there, always visualization is not possible. But the best, so here is one thing is there. See, convex set is, we are, see, this set is a convex hull is, we are creating a convex set using these points. Okay,
Yeah.
this is one thing. I'm using this definition only. That is also true, that intersection of all possible convex set, all possible convex set which contain these points. And the second, the convex set is what we have already given a set, and we have to check is there a convex set or not. But here is convex hull is, we have given some point, and we are creating. See, this is we are, this is what we are creating. No? This is one set we are creating using these points, and the set is how it set is KSA using the convex combination. And now this whatever the set we are getting, that is going to be a convex set. Okay. And intersection of all possible convex set. Okay, all possible convex set. So in that, if you see this is, if you think about this xy plane, so this xy plane is also a convex set which contain this point, also this point, all point. Then whatever this set we are getting, sorry, this figure is we are getting, that is also a convex set which contain these all 4 points. Is there any, if you are taking this region only, or maybe this region only, so is this, so this is going to be a convex set, but is this contain this one, other points? No, right?
Yeah, it doesn't contain other points.
So I
Yeah.
want those possible sets which contain all this. So this could be a, no, this contain this set, this region contain all points, this region contain all point, a circle containing this contain all point, but this is a smallest region which contain all point.
Mhm.
Are you able to get it? Only the
Yeah.
rectangle one, which is so is going to be the smallest one, means intersection of all possible convex combination, sorry, all possible convex set. This is going to be the smallest one which contain all, means all this 4 sets, sorry, this 4 points.
Yeah.
So can you use the Lagrangian here and you can deduce that it's basically a square, which is basically the area.
Why
Which
you
is,
are using Lagrangian?
to evaluate that this area, this is basically a square, which will be capable of eligible for a convex set.
Now, why you are using Lagrangian here?
Because I'm using the minimum area which should encompass these 4 points. So those are the conditions if I put, and it has to be having the minimum area and having these 4 points.
So
Can
how
you
you will use that?
So that's what I'm saying. Can you use this one?
No. So no.
So I make an equation y is equal to 2, x is equal to 2. These are the two equations of the two vertical and horizontal lines.
No. That would not. There's no connection of that. And okay, let's do next problem. So I hope all of you got why it is so. We have two methods. One is a direct option wise you can choose, and the second one is whatever the definition we have the convection.
So just a observation. Usually in our elementary graph theory. So it's in basic graphs. What any any greater than equal to or less than equal to graphs, we actually plot the graph and you take two arbitrary points on the left side and the right side, and you decide the area which needs to be hatched or which satisfies this point. So if you use same concept and if you use take arbitrary points, will that be okay?
You can try. So
I take
you can
arbitrary
try.
3-4 points within the area and some beyond area, and if it satisfies, obviously, just for example, this point, there are 3 points are not within this rectangle, or the square or rectangle, whatever. The fourth point actually falls inside it. So looking at that, we can also decide. No?
That will not be the convex set.
Which one?
That you are saying that if 3 points are outside this rectangle, only one point is in
Because this is a closed boundary. So if you take 3 points, they're outside the boundary.
My
And
friend,
one
sorry, which points you are referring to? I'm not able to visualize what you
Okay,
people
so Srikanth, sorry. So let's leave that. Actually, says I don't know how he's using. So let's leave that because see we cannot do with how. So if you are thinking, you can try
No,
first try
what I'm
and then
saying
let
is
us.
you
Sorry,
can you
hello.
can you can see the points, no, sir. You can see the points, the 3 options, 3 points given. None of them are within this boundary, except the last point. That is what I
So
mean to say.
so first try yourself and then let us know. Then it would be good.
Okay, fine.
Can you do that?
Okay.
Yeah, first try yourself. Then that would be good because.
Okay, I'll just try it
Directly
and
see
I'll do it
this
and
one I'm
put it
not
in the Discord.
I think see I didn't did that, but
I'll
it should
put it in the discourse. I'll do it and put it in the
yes
discourse.
yes we have given yes is a convex set is given. We have some 4 points. Which point must be the part of the convex hull formed by this point? This is very easy. All of you try it. So here it is very easy. Just use the definition. We have 4 points, and all should be within 0 to 1. So is falling between 0 to 1. And if you sum them all, it should be 1. So use 2 conditions and answer them. So directly you can neglect the option B. The reason is it contains negative numbers. Okay. And C option is also directly you can neglect, because very easily you can sum them all. This all. It is going to be not easy to sum them all. It will be not 1. So only we have D and A option. So I don't know which option is true. So all of you have answered.
Sir, D option, if we add all numbers of A option, it's greater than 1.
It's greater than 1. Sorry, which one? Option
Sir,
A
in
is, yeah.
A option, if we are adding all the values, they are greater than 1.
Yes, yeah. So if you add these all, it is going to be, and you see, it's already giving 1, these two only. So if you first two, if you add only, this is giving the more than 1 even, not even 1. So only the option
Sir,
D is
2.
going.
It's giving 2.
So it's giving 2. Yes, this is yeah, and only this one is which have. So if you're summing them all, the coefficients it's giving. So this is very easy, and we just use our definition of convex cell. So let's do the next problem. Okay. So we have a storage set. Okay, a storage set is to built in a shape of box. Okay, of a square, a square box. So it is the wrong thing. Is there? It should be a box. So height would be also there with a square base. Okay, square base is then x and x. it is to have a volume of 800 cubic meter. The concrete for the base cost is 50 per square meter, and the material for the roof cost is 70 per square meter, and the material for the sides 60 per square meter. What will be the constraint equation? So height is not mentioned, but I am looking, height is all in the options we have. So use that h as a height. The one response, is it tough?
Sir, actually, this question is not clear to me. I mean, no hurry, but I request you to discuss this question and.
Okay.
Yes, sir.
Okay, 50-50. Okay. Oh. Yeah, the cost is not given here.
I didn't understand how to approach. I mean, something is missing is what I feel. But I thought, okay, how others are able to do, I didn't understand.
Yeah, less information. How will constrain it? So this is a meeting.
Also, even if I just at a high level, if I look at it, sir, ignore the rest of all the things. At least, let's say, if we take the concrete for the base cost 50 per square meter. So we know the base is x into x area. So x into x area into 50. So 50 x square should show up somewhere, but which I fail to see.
That
So
will be sum up for the upper part.
sorry.
That upper part will be also square, right? So it will be x
Oh, oh, the material for the roof cost 70 per square meter.
that will be 120 x square.
Okay. Oh, so that's why 120 x square is showing up. Okay, makes
Yeah.
sense. And the
And
material for the slides, okay, sides cost 60.
three sides maybe. One side will be open, I think.
Yeah, all that is fine. Then where is the less than? I mean, no, 200 or what is the constraint? Where is that?
Means
Oh,
volume is given 800. So we only want the surface volume kind of.
no. Cost. No, with respect to cost, I understand you calculated the base cost, roof cost, and side cost,
Yeah.
and that should be equal to something or less than. I mean, it has to happen within some, let's say, 1,000 rupees or 1 lakh or something should be there, no? So where is
No,
that?
volume is given. Total volume that I think 800 cubic meter. Right? It's given.
Yeah, how
It's
do
a
you connect? How do you connect volume to the cost?
what?
How do you connect volume to the cost?
Volume means not. Yeah, that's
Because on
completely
the left
different.
side, whatever we calculated 120 x square plus 60 into x and h, let's
Yeah,
say that is the cost, no?
yeah, got it. Yeah,
So how do you convert our the volume to the cost? That's my point.
yeah, correct. How to connect?
Yeah, the cost is given. How this could be? This h square is hx square is less than 50. Yeah, this part. I don't know how it could be. This is a missing question. We spent time here also. Let's do the next problem. Then how I can do this?
So should I say how to approach this one?
Yes.
Yeah. So we have been given the volume as 800,
Hmm.
which is basically the square of the area into height.
Hmm.
So height becomes 800 by x square. Height becomes 800 by x square, isn't it?
Hmm.
Yes, correct.
And the surface area is 4 times x into height plus 2 times x square. If you take a derivative, we'll get a relation between x. We'll get x is equal to how much? We'll get a value of x and we will put it we'll get the value of the surface area. So that comes to 200.
Okay.
Can you come in a last point? I mean, 800 by x square is this?
800 by x square. 800 by x square is the height.
Correct.
And surface area is what? 2 times x square plus 4 times x into height. Correct?
2 times x square, correct, plus 4
plus
times.
the 4 side, yeah. The 4 walls is 4 times x into h.
Correct. Yeah.
So you get an equation between x and h.
X and h.
Yes, you get a s is equal to in terms of x and h, na?
Oh, surface.
So you just replace h by 800 by x square and try to take a derivative and compute it to 0. You will get the value of x.
Oh, 1 second. I am seeing it. 1 second. 800 by x square is equals to 2x square plus 4xh. Okay. 4xh. H అంటే again 800x square. Okay. 800 by x square equal to 2x square plus 800 by x square. So x 3200 by x. 2x cube plus 3200 by x.
So here
800
height is given, height is h and weight is base is x square. So the cube is volume is going to be this one, right?
Yes. Yeah.
So one option is given there, this.
Surface area.
And if we come up to with the surface area, so we have
24,
volume is given.
Yes.
So surface area is
if you put surface area in terms of h and x and replace h by
so what you are getting the equation?
We're getting say 2 times 4xh plus 2x square is the surface area. 4 times xh.
xh, okay.
Yeah, plus 2 times x square.
Plus
If
2
not
times
x 4xh plus 2 times x. Yeah, that is basically the surface area. You replace h by 800 by x square.
So here h is equal to
800 by x square, right?
Okay, so surface area is going to be 4
times
and
h is 800 by x square.
4 into 800 x square into x plus 2x square.
Right.
So here is x and x is cancel out. So we have finally 3200
by
on x.
Yes, 3200 by x.
So this is a surface area.
Plus 2 times, 4 times x. 4 times x. You will take a derivative of that now, sir. You will take a derivative to,
So why you are taking derivative?
I'm taking derivative to see that the maximum volume which can get into that surface area with that volume.
But there is no, so if you're taking derivative, okay, maximum volume you will get, so what is going to be that?
So now I'll get the value of x and h and we'll put that in the equation of s, we will get a surface area. Optimum.
Okay, so here, what is the value you are for getting for x?
So this one is 3200 by x plus, this is 2x square. If you take that comes to, so derivative is 3200 by.
So okay, fine. You are getting the maximum volume.
Yeah.
Actually, it's not even maximum, dear friend. I think they have given the volume to match to 800.
Yeah, only the volume is given.
Volume is given, nothing else is given. So this is the only way you can approach. Otherwise, there is no other way. There is no other data.
But
there is no other data given. No other data is provided.
Okay. What is the next step you tell, and how do you arrive at the? Okay, after this, you are saying derivative of surface area.
Yeah, after that I have not even calculated. We can find out from there how much x and h you will get, and we'll put it in the s, and we'll put that value of s as a less than greater equal to or whatever.
See, by derivating that S and equating it to 0, what you are trying to do is you are trying to maximize or minimize the surface area, right?
Right.
What is that? Okay.
What there is no other way now, because otherwise the data is insufficient.
This is a totally data insufficient. Even if you get that, how will give the constraints? I didn't check it. So sorry, let's leave it.
Is the
Otherwise,
question in the
we'll waste
PYQ,
more
sir?
time on this.
Is the question in the PYQ or some other?
No. This is okay. So let's leave it. Otherwise, we'll waste more time
Okay,
on
we'll
this.
go to the next question.
Yeah. So okay, this is previous one. Will object. No, why is came? Okay. Let's do this. Which of the following is a convex function in R2? So easy.
Yes, sir.
Even if we draw the graph, easily we can do it.
You can do the differentiation matrix and then do that. So to differentiate.
So you are creating a Hessian matrix, huh?
Without
to
Hessian, how we
differentiate.
can do?
Without that, actually, I mean, by looking at it, we know 2x square plus 5x square is like a parabola kind of thing with some multiplying factor of 2 and 5. So it will be, it's like a cup, erected cup. And so the epic curve of that curve is going to be, what do you say, convex. So first one is the right answer, but if you go to second, because it's having minus sign, it is an inverted cup shape, which is
Yes.
and whose epic graph is not convex.
Yes.
And likewise, C is something like a saddle. You get something like a saddle. You have along the X, you'll get the erected cup, and along Y-axis, you'll get the inverted cup.
Okay.
So that is again not a convex function. So my answer is only A.
The graph only we can easily do even. Otherwise, see, we can neglect option by the B option is easily. See, we know, right, this x square plus y square, even ax square plus by square we have. If A and B are positive, then anyhow the case is that this cup will get.
Yeah, it's a erected cup or upward cup. Yeah. So correct. That is convex.
And if you think, if you take the point, so inside that is always going to be a convex epigraph definition. Otherwise, best thing is if you don't want, if you're not able to draw the graph, then we have a function, and if it is ax square plus by square, then gradient is going to be 2, so 2a
2ax 2by.
and if you draw the Hessian here, so the double derivative will sorry, we don't want this. So if you want to derivate with respect to x, so fx is going to be 2ax, f double x is going to be just 2a. So this is 2a and 0, I think, and it is yy and sorry, this is going to be 2b, 0, and then finally
2b.
2b. So now based on that, so these two are eigenvalue anyhow. This is a diagonal one. So it's depend on, so it is going to be positive definite when a is greater than 0, b is greater than 0. Both should positive. Then it is going to be positive definite, and then it is going to be a convex function. So directly now from here, if any one of them is going to be negative, so it is not going to be a convex function. So C option is not going to be there. B is already with that, we can say. So the coefficient should be positive.
Can you go back to that working where you have done? So here, what did you do after formatting the matrix? 4AB.
So this is a Hessian matrix.
Correct.
Now, what is the eigenvalue of it?
Eigenvalue. Yeah, 2A is 1.
Eigenvalues are going to be 2a and 2b.
Correct.
And we want, if you want this should be positive definite, then this should be positive in both cases. Then it is going to be positive definite, no, because these are the eigenvalues.
Sir, if eigenvalue is 0, then?
So what is the case? So I forgot that it is a positive definite. So not only the positive definite, positive semi-definite.
Yes, sir.
If it is a, this one is a positive semi-definite, then it is going to, so let's make it again, the constraint is greater or equal to 0. That's all. So by this way, you can always, you can do easily if a kind of you have ax square plus by square. Easy, no? This is easy. You can easily do with the Hessian. So only A option is correct. Let's do next problem. The minimum value of the function subject to constraint this. Okay.
Sir, what is the answer for this one?
Is it 1/3?
Yeah, 1/3.
Now, can we not imagine this like a cake, cutting it into 3 halves?
Sorry?
Sorry, cutting it into 1 half. Can we not imagine like a cake, right? Circular cake which has been cut by x plus y plus z. And then
This is a 4-dimensional. If you want to imagine, this is a 4-dimensional, so we cannot do this.
but is it not 3-dimensional?
No,
Because of the
no,
three
no, no, no.
axes?
So just a second. So this is going to be, no, we can imagine, but if you don't want the graph, no. This plane we can draw, but this one is. No, this would be difficult to open. Sorry, draw it. So this plane we can draw, but this one is. This is a function, no? We need 4-dimensional if you want to graph. So whenever this is a theory that if you want to draw a graph, we need one more dimension. So here it would be difficult. Yeah, we can draw the plane.
Actually, this x squared plus y squared plus z squared is a paraboloid, and that x plus y plus z is a kind of plane under the paraboloid. Right?
Yeah, this is a paraboloid.
Parabola, yes, paraboloid.
So visualization would be difficult here. So let's do by whatever we have a theory case, that Lagrange multiplier. So we have function f of x, y, z, which is of x square plus y square plus z square, and we have a
Basically, what you're
constraint.
doing is you're doing an approximation which plane touches at least one point of that x squared plus y squared plus z squared.
Sorry.
So x squared plus y squared plus z squared is some sort of curve, or say it's parabola, and the x plus y plus z is the constraint. So it has to touch at some minimum point where everything above that x plus y plus z is there.
No, if we do with the 3-dimensional where we can visualize, so if we do it, so this is a case where we want to find minimum value of the function.
When you're doing a lambda, you're applying that with lambda, you're doing it lambda into x plus y plus z minus 1, and then you are going to solve for x, y, z. Become as 2x.
Sorry.
Yeah.
Here, if we suppose we have a function of x, y only, so and the function is this one, then the graph is going to be this one, and constraint is given. This means if you want to draw the plane here, so this is a plane. So whatever the surface is, within that we have whatever the points we have of the function, which one is going to be minimum within that?
Minimum per. The same thing we are doing with the now.
On the plane only. That is what the meaning here. But we have this is in 3 more dimension. We know this is a 4-dimensional. If you try to draw this, so it would be difficult. So let's do by the Lagrangian. So we get a Lagrangian equation here. What? Del f. So this is a equality constraint. So this is a equality constraint we have. So this is going to be what we want. So this is lambda g gradient of g, and we'll equate it to 0, right? This is how it is. So here gradient of this is going to be 2x 2y 2z plus lambda time. However, somebody is used to write this one. You can write that also. Either this one, whatever you want, you can all actually give the correct answer. And here this is going to be only 1 1 1, correct? Is this correct? Is this calculation is fine?
Yes, sir.
Yes, sir.
That's correct, sir.
So this is 2x plus lambda
This
equal
is
to
right.
0 will get 2y plus lambda equal to 0 will get 2z plus lambda equal to 0 will get. So finally we have this one. So we can substitute each time, as you know, this one will give lambda by 2. So x will give lambda by 2, y will give lambda by 2, z will
No,
give
minus
lambda by
lambda
2.
by 2.
Sorry,
X
minus lambda,
is
all
equal
will
to
give
minus.
lambda. And now we'll substitute these all in the constraint one, which is going to be minus lambda by 2 plus minus lambda by 2 minus lambda by 2, all will sum them if the sum is 1. So finally here we'll get lambda equal to minus 3 lambda is equal to 2, correct?
That's correct, sir. Lambda equal to
And
minus 2 by 3.
lambda is equal to minus 2 by 3. So finally here we'll get here lambda is equal to then 1 by 3.
X
Sorry,
equal to 1
x
by
is equal
3.
to
1 by
1 by
3.
3.
X, Y,
So
Z equal to 1 by 3 each.
yeah, this is going to be 1 by 3, 1 by 3, and 1 by 3.
Lambda is supposed to be positive, right? Should be
No,
above
here
0.
is lambda is not going to be positive because we have a equality constraint.
No, it can be positive or negative, sir, for an equality sign. But
For equality,
but it all depends on how we take it. I mean, if you equate it to lambda 1 2 3, then lambda would come as positive 1. I mean, a positive value, because you have taken it as the gradient of f plus lambda into gradient of g equal to 0, you will get negative value. But end of the day, answer is same. I got
answer is same.
yeah.
Correct. Either you can go, or both are actually correct.
Yeah.
However you want to go, you can go and get the correct answer. Here we are very free because of lambda is going to be any real number. There is no constraint on on lambda. If it is inequality constraint, then we have to be fixed with this one only. And here the lambda should be positive. If you are getting lambda is negative, then that is not going to help us any kind of value. Will give. Only will take the positive one. But here we have only the equality constraint, so any lambda could work. So x, y, z we got, so minimum value is going to be, so we want minimum value of the function, so this is going to be 1 by 3 square plus 1 by 3 square plus 1 by 3 square, which is 3 by 9, and 1 by 3 finally. Okay, this is good. So let's do next quickly.
So there it was asked what is the value of gx, not fx.
No, minimum value of the function f.
Of the function, yes, of the function. Right. Okay.
What is the boundary value of y so that the function does remain convex? Easy. We have done on this already, previous one. Want convex, make it convex.
So for any value of y, it will be convex only, sir. No, sir. I don't see any polynomials.
Yeah, correct.
C is the correct answer.
Yeah, here is we don't give any, we are not able to give any constraint. So somebody suggests D also, none of this. Okay, let's do. All of you try it.
So for a convex function, the coordinate is like x squared plus y squared. If it is positive, then it's a convex. It's a thumb rule.
Yes. So that's are actually doing it. So two up. So who have chooses D option? Can we answer why you are choosing D option? None of this you are not getting it.
The value of y plus 1 should be positive, no? So that is positive only if y is greater than minus 1.
No, y plus 1 has to be positive. Even if y plus 1 is negative, y plus 1 whole square is positive anyway. So there is no constraint that y plus 1 has to be positive.
Yes.
Question like that.
In sum of square terms, if it is positive, it's convex. That's the thumb rule.
That will always be positive.
For any value of x and y, the given function will always come up with a positive value only.
Positive.
So
There was one question like this in the graded assignment also. But there they have asked the value of
Yeah.
x.
there the condition is, I think, slightly different, where we can come up
For a convex function, the Hessian matrix of function must be positive, semi-definite.
You see, it is actually, so this one is very simple. See, for any value of y, we substitute here. If it is x minus 3 square plus y plus 1 square. So here, if you want here, this is, kind of this one only. Any value is going to be make this. So any value can, either if you don't want, you can go with this Hessian matrix. This is easy. C option is always going to be correct.
Yes, sir.
Sir,
Yes.
actually, I have not followed the week 6, 7, 8 sessions properly, sir, for some reason. That's why actually I know the answer for this and I know how to do it and all, but through Hessian matrix, I'm not aware. What are the possible different conditions that positive, definite, semi-positive, those things I was not aware.
Only within only one word, if the eigenvalues are positive, positive definite. If positive and 0 is there, positive semi-definite. Only negative, you have negative definite. Negative and 0 is there, negative semi-definite. That's all.
Oh, okay.
Sir, can you make a Hessian matrix for
There
this?
was an error in one of the questions in the quiz too. They had said it is a positive definite, and then they had given for value of 0 also. Correct.
Okay. Okay. Let's do the next problem. Last problem. Which of the following Hessian matrix correspond to the convex function? Easy.
But the answer, it is multiple choice. It is taking accepting only one, sir.
Which of the
It should be a multiple choice because 3 of them are
Yeah,
correct.
but it is accepting only one.
Only one is being accepted.
That is a problem.
First, second, and fourth. All the 3.
No, first will not be there.
Why?
Sir, second and fourth.
Second and fourth will be there.
Minus 5 into minus 3 will become plus 15, no?
Just need to find the eigenvalues here. So easily we can do.
Oh, the eigenvalues have to be positive. Great. Then B and D.
So all of you try it and easily can get. So multiple option is correct.
Sir, just for my sake, if you don't mind, can you help me with this? I am not comfortable with this approach, sir, as I was saying.
Eigenvalues you just need to find for
Okay.
each option.
Okay, so if I find the eigenvalues for the first one, I'm getting negative values.
Yeah, what is the first one eigenvalues?
I have not yet found, but they are coming negative, sir. Minus 8 plus or minus 8 minus 44. So 44 square root of minus 8 plus or minus square root of 20. So I think both I'm getting negative, sir.
Yeah, so then it is not going to be positive definite.
Okay, so only if it is positive definite, then it is a convex set.
Positive semi-definite.
Positive semi-definite.
Only it has to be positive semi-definite for it to be convex.
Convex.
Oh, positive semi-definite. Okay. For all other cases, it will not be convex. Okay. So for positive, for it to be positive semi-definite, so one has to be positive and other one has to be 0, no, sir?
Yes, either positive or 0 will
Positive.
be make them, yeah.
So no, so all the eigenvalues have to be either positive or can
Or
also
0.
be 0, sir.
Yes, or 0.
Okay. Okay.
Then it
Positive.
is positive definite. Sorry, positive semi-definite.
Okay. So when will it be positive definite, sir?
Only the positive you have.
If all are positive only, not 0, then it is positive definite, sir.
If there is no 0, then it is going to be, if it is only positive, there is no 0, then positive definite.
Oh, okay. Okay.
And 0 is also available in that along with the positive eigenvalues.
Okay.
Then positive semi-definite.
Okay. And likewise
If
for
it is
negative also.
yes, for negative, all eigenvalues are negative. Only negative you have, then negative definite.
Okay.
If negative and 0 also there, then it is a negative semi-definite.
Okay. So sir, I understand this now. What does positive definite mean and what does negative definite mean? Do you mind to explain if you don't
Just
mind?
definition. It is, you think it as a just definition. We have some matrix.
Okay.
We call it as a positive definite. You
Uh-huh.
can say if this property, we can call that matrix as a positive definite matrix.
Okay.
It will use some letter case, you can see.
Okay. Okay, sir.
Okay, so that's all. This there all slides we have done. Only one missing slide. This is wrong. Anyhow, it is wrong only. We have some need because there is no y I mentioned, but now in the second problem it says y is there. What is the use of y now? Totally sorry, we don't have sufficient data. Okay, that's all.
Sir,
Anyone have any?
sir,
Yes.
can you just show the last question once, sir? I want to take a screenshot.
Okay.
Last question.
This one.
Yeah.
I'm not solving here because all of you
Yeah.
are many times you are solving the eigenvalues, eigenvectors.
Yeah. No problem, sir. I'll solve it offline. No problem.
So can you show the question number 6 once again?
Okay, just a second.
6, yeah, next one. Yeah, this one. No, before that, number 5. Yes, I'll just try to. Okay, sir, thank you.
Yeah, if you get the answer, share it with us. Hello.
Yeah, I'll try to do what is the problem.
Yeah, fantastic.
Okay, thanks, Priyan.
Thank you,
Thanks
sir.
for joining.
Thank you, sir.
Thank you all.